So this is another lesson on trigonometry, and we're gonna learn about the sum and difference formulas. So let me just write the title: sum and difference formulas. Now what this means is that, for example, when we have angles, when we want to find a sine, cosine, or even tangent values of angles that are the sum of like two angles that we're very familiar with. For example, if the question says, hey, what's sine 105 or something, then we realize that 105 is 60 plus 45, and we want to do something about this because we know sine 60 and we know sine 45. So we want to use that fact to find sine 105 degrees, but we don't know the formula, which is really frustrating. So today let's just study about how to do this. So the formula for like the sum of two angles in sine is gonna be like sine alpha plus beta equals sine alpha times cosine beta plus cosine alpha times sine beta. If we apply this into the sine 105 degree example, we have this is sine 60 degrees times cosine 45 degrees plus cosine 60 degrees times sine 45 degrees. So this is equal to root 3 over 2 times 1 over 2 plus 1/2 times that's definitely not 1 over 2, times root 2 over 2 times root 2 over 2, so this is root 6 minus root 2 over 4. That's just sine 105 degrees, pretty simple. Let's try another example because right now we're kind of confused with this formula. Okay, so let's try sine, sine, let's say 165 degrees. Okay, so firstly we need to break down sine 165 degrees. So let me just write this below, okay? There's not enough space. So sine 165 degrees. Realize that 165 is 120 plus 45, and 120 is 60 plus 60. So, and also we already learned our unit circle properties, and we also learned our trig properties. So essentially we also know that 120 is actually just we know that 120 is just 180 minus 60, right? So we draw the unit circle, even if we forgot about this property, like I already did. So that's why I'm actually demonstrating how to draw the unit circle. So we draw the unit circle, and we know that this is 60 degrees. Well, that's definitely not 60 degrees. If this is 60 degrees, and this is 120 degrees, note that the sine value for 120, so like this is equal to sine 120 times cosine 45 degrees plus cosine 120 times sine 45 degrees, right? So notice that the y coordinate here looks about the same, and we can prove it, but I'm not going to prove it. It just looks the same, so I'll just eyeball it. I'm going to assume that this is the same, and my assumption is correct. I'm going to assume my assumption is probably correct. So the sine value of 120 is the same thing as sine 60 degrees times cosine 45 degrees plus, now notice the cosine 120. This is a negative, this is a negative coordinate, so it's negative. It's probably going to be negative cosine 60 degrees times sine 45 degrees. So this is just going to be wait, what is it? Oh, this is just gonna be root 3 over 2 times root 2 over 2. Times root 2 over 2 minus 1 over 2 times root 2 over 2. And this is actually root 6 minus root 2 over 4. And I just realized something. I made a mistake over here. This is a plus sign, so this is root 6 plus root 2 over 4, not minus. Okay, so this is our answer for sine 165 degrees. Let's move on to the difference formula for sine. So we have the sum, we also have the difference. So we can have sine alpha minus beta equals sine alpha times cosine beta minus cosine alpha times sine beta. So, notice that this formula looks kind of like this formula over here. Like, it's like alpha is 60 and beta is 45. It seems like that the sine of 165 is the same as the sine of 60 minus 45, which is sine 15. And that is actually correct, because if you draw the unit circle, essentially this is 15, right? And the sine values, so the sine value will be this much, which is positive 165. So this is going to be 165 because this is going to be 15, and the sine value is going to be the same. Like, you can just eyeball that. So actually this is actually correct. So we know that. So if we use the difference formula of sine to find sine 165 degrees, we could have done sine 180 degrees minus 15 degrees. So we can try that, I guess. Okay, but the major problem here is kind of like we don't know what sine 15 degrees is. So that is the major problem over here, but otherwise we could have done that. Okay, so let's say we try to find sine 15 degrees then. Well, sine 15 degrees is just 45 degrees minus 30 degrees, right? Pretty obvious. So this is just sine 45 degrees times cosine 30 degrees minus cosine 45 degrees times sine 30 degrees. So this is root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. So this is root 6 minus root 2 over 4. So that's that. And notice again it's the same as sine 165 degrees according to our properties. Let's try another example for the difference formula for sine. Let's say we try to find sine sine IDK sine like 35 degrees. Does that exist? I don't think so. Try to find sine, so 120 minus 45, let's try to find sine 75 degrees. Now we can do this using the addition formula. Like, this is 45 plus 30, but this is also 120 minus 35. Okay, wait, this clearly does not work. Okay, anyways. Okay, let's do 65. So that is 120 degrees minus 45 degrees, right? So wait, never mind, it's 75 degrees. Anyways, so this basically means we can rewrite this as sine 120 times cosine 45 degrees minus cosine 120 degrees times sine 45 degrees equals 120 degrees. So sine 120 degrees is just gonna be sine 60 degrees times cosine 45 degrees. This thing is going to be negative, so this thing is negative sine, this is negative cosine 60, so negative is plus cosine 60 degrees times sine 45 degrees. So this is equal to root 3 over 2 times root 2 over 2 plus 1/2 times root 2 over 2, which is root 6 plus root 2 over 4. Okay, so let's move on to like cosine stuff. Next lesson, I guess.